So we'll create an instance of the usart config structure. I'm going to call mine usart config, and we'll go right click on this structure and go explore it. And basically you have a series of enumerators that are going to set your data order, most significant bit first or least significant bit, your parity, your stop bits, your character size, and your multiplexer settings for your pins. So that's what this structure does, and what we'll be doing is we'll call a function, a built-in function that's going to set this structure we just created, set it to its default settings, which you're generally supposed to do. They recommend that, and then we'll modify those settings a little bit in that structure. So right here you can see in the example, I'm going to call the usart get config defaults function, and then setting it the pointer and the parameter as a pointer, and then we'll point that pointer at um, the instance of the structure we just created right here, and then because it's pointing at this structure, this function will then modify through the pointer, modify the members of the structure, setting them to their defaults. And then after that function is finished, then we'll use the dot operator to directly access some of the members of the structure that have already been set with defaults, and change those to the settings that we want for those members. So anyways, I'm going to call this function then usart get config defaults. So here it is here. Notice that we have a pointer of type usart config, and so we have to give it the address of the structure that we want it to point to. So we use the ampersand and saying that and where's our structure? Where's our structure at? Well, that was it's right here, my usart config we just created. So we'll point at my usart config, and that's the only parameter that this function takes. And oh, did I go over that? What does it set it to? All right, so it does first. This function does um, does an assert statement. Assert statements are, like it says, sanity checks to make sure your code doesn't have some major flaw in it. At this point that it will actually has a config structure that you can point to. So it's a basic check. And then here you can see that it's using the arrow operator because it's a pointer, and it's pointing to the instance of the usart config structure. Then we use the the arrow operators to change the members. So here you can see it's changing it's setting the data order member of the structure to usart data order least significant bit. And each one of these have a defined statement, or they're an enumeration. In this case, enumeration of type usart data order, and then it has the setting the enumeration equal to the SERCOM register control 8 data order register, and sets it for you. And then it does so for each the different parameters, for the serial communications. If you're transferring asynchronously, which is the default set to, there's no parity set in default, stop bit set to 1, character size to 8. The baud rate is defaulted to 9600. Receiver enabled true. Transmitter enabled true. Clock polarity false. Use external clock false. Here your mux settings are set to default usart RX1 and transmission. Your pin settings on your board. We'll get to that soon. Clock generator source to clock generator 0, which I think is the 8 meg oscillator, which is defaults to, and then that's divided by 8 to give you 1 meg on your MCU. And then notice here that your PinMux pads. Remember I said pads are a series of 4 pins, and that the pads can be assigned to any peripheral module that you want to. They have the SAM chip set up that way, so you don't have dedicated pins to each peripheral. You can assign them as you want, or if they're not assigned, then you can assign them as a general purpose input-output pin for something else, not even a peripheral, whatever you want to use, an LED or whatever. So in the default setting, they set these members pad 0 equal to PinMux default. So we'll see the defined for that, and it's set for 0. So it's basically they don't assign anything, any of your pins with the default function, because obviously depending on what board you're using or what part of the board you're going to use, you're going to have to set the pins that are using for the SERCOM that you're using. In our case, the virtual COM port. So let's go back and set those. We'll go back to our example. So we've set the defaults, and then here we'll change some of those defaults. So to the dot operator, like I said. So let's find our structure name and start assigning those. Hit the tab. Then you can see all your members here. Yeah, so what do they have? What do they set it to? Config. So the first one we set is the mux multiplexing. Our multiplexing settings. And here you've got your defines, which remember when you pick your board, these defines are set up for you already. So in this case, the mux setting for your receive and transmit pins. And because we're using the onboard debugger virtual COM port, that's the defines that we're going to use in this example. Hit tab. What's our next one? Alright, pad 0. So pin mux. Pad 0. We'll set equal to our onboard debugger SERCOM pad 0 define. And we'll do the same for all 4 pads. And just let's go check these out then. So right click on this defined, and here you can see it. It's a defined to another define, which is your usart receive and transmit enumerations, or yeah. So your multiplex settings for your receive and transmit. And I don't understand. I guess you're using a mask to set the pins, but I can't explain this in any detail. I don't get it yet. And let's take a look at pin 0 here. I mean pad 0. So pad 0 in this case is port A22C. SERCOM 3, which is our virtual COM, our onboard debugger virtual COM port, uses SERCOM 3. And we go to, okay, so you can see here on our board that the port A22 is the SERCOM 3 UART transmit pin. So that's basically what we're doing here is, setting the proper pin for serial communications. And I'm trying to think, that's transmit and receive. And then I don't know if these ones are used. I can't remember. Yeah, see, 3 and 4 are pin mucks are unused. So they're not even hooked up because we don't need them. And these could be, because it's a multiplex, there's a multiplex driver, then you can set these pins to do something else, light an LED or input for a button, whatever you want. But in this case, we're not using it. All right. And we still have to set our baud rate. There's our baud rate. And set our baud rate 9600.